I'm Stephanie Scaglia from Dr. Schaefer's Period 3 Marine Biology course at Harker. And our final project was to choose an organism and kind of examine it and go deeper. And these were organisms that hadn't really been researched much, so I kind of made my own speculations and kind of tried to answer my own essential question. So that's just the gist of what this will be about. So the question that I asked was, why are six-gill sharks still around, and how did they survive? And what impact did evolution have or not have on them? To kind of give you some context on this, usually it's just five-gill sharks that we talk about and hear about the most, and six-gill sharks are a little more ancient. Talking about ancient, going into taxonomy, these creatures, specifically the blunt-nosed six-gill sharks, which I kind of zeroed in on, belong to the kingdom Animalia, the phylum Chordata, the class Chondrithes, the order Hexantiformes, family Hexantridae, genus Hexanchus, and the species Hexanchus griseus. In this chart, if you would kind of direct your attention over to the top at the right, you can see the order Hexantiformes, and then over on the left, there's the suborder Squalomorphae. And I found that Squalomorphae contains many other 6- and 7-gill sharks, such as from top to bottom actually on the first 5. It's the frilled shark, broad-nosed 7-gill shark, sharp-nosed 7-gill shark, and the big-eyed 6-gill shark. Not counting H. griseus, which is the blunt-nosed 6-gill sharks. Those are just the common names. I thought the suborder was important because it kind of lets you know that out of all the sharks, which are under Hexantiformes, there's this suborder, and those are the 6-gill sharks. And there aren't that many, as you can see, but they're still around, and they have their advantages. So to show this video, or just part of this video, if it'll load, that would be great. Perfect. This video shows a 6-gill shark swimming within the depths of the ocean, and I put the video in here so that you, the viewer, could just have a solid image in your mind while I discuss the specifics of this shark. As you can see, the creatures move relatively slowly, and they tend to be found alone rather than in groups, and their size is about 1.5 meters to 8 meters in length. They are brown or gray on the top with light-colored undersides and stripes on their side, which you can kind of see right there, the little glint. And all of the fins have a white surrounding on the edges. You can kind of see that right there on his left fin. And their eyes tend to be bright green. Right now he's turned away, so we can't see. But their bodies are heavy with broad heads and rounded snouts. And to talk about the mouth, we're going to move on to the next slide. So kind of continuing on the bodies, their mouths have 6 rows of saw-like, razor-sharp, comb-shaped teeth. On the left, there is an image of male jaws, which are pretty similar to female jaws. And then going one photo to the right, there's the male teeth, both upper and lower, and then female teeth, also upper and lower. The females and males have pretty similar jaws and teeth and all that. So there's no major discrepancies there. Next, I'll talk about the key feeding behaviors. And I'm kind of going to spend a lot of time on this because I think this is what makes the 6-gill sharks really stand out, and I think this is mostly what answers my essential question. But first, on the right, this is just a baby 6-gill shark with bait in its mouth. So they're pretty small when they're babies. First, let's talk about food capture. They primarily use ram capture and suction, and ram capture is where they crush the food between their teeth and then just chew it up. So they go at the food and they chomp on it. And then suction is used mostly for larger items if they can't really get their jaw around it because their gape is too small. And they literally suck the food towards or inside them. And sometimes they use ram capture, and then they use suction in order to get it down their throats. Next, for manipulation, six-gill sharks are able to manipulate their prey. As in, if the prey is too big, they can twist the bait or saw it in order to devour it into smaller chunks. And this is really useful for if prey is too big, they can still eat it. Right, so that doesn't limit them to what they can hunt or what size fish they can eat. Leading into bite composition, excuse me, contrary to common belief, these sharks have a bite time of 29.97 FPS, which is really fast, and it's similar to that of a great white shark and a tiger shark. Many people would not suspect this because of their sluggish and slow nature, but they're pretty fast, which I think is why they're still around and why they're successful. But anyways, continuing, there is a snout lift and the food item hits their upper jaw first, which is uncommon in most sharks. Usually it hits both the upper and lower jaw. With the preparatory bite, it comes with a limited and restricted slow movements of just the cranium and the mandible. Unlike great white sharks, the snout did not have to come into it was found that the snout did not have to come into contact with the food item before closing. I saw this as a plus because it aids with their feeding if they have more control over their jaw, and that gives them an evolutionary advantage, as I've been discussing. For upper jaw protrusion, that's mostly done with 7-gill sharks, so I won't spend a lot of time on it since I narrowed in on the 6-gill. But it actually decreases the mouth closure time, and 6-gill sharks are capable of doing this. It hasn't really been found why they don't do it as often. Maybe because they're just better at actually just regulating their jaw, so the mouth closure time doesn't matter as much. But it happens when, the upper jaw protrusion happens when the gape is at its widest. And lastly, for modulation, 6-gill sharks are said to be able to regulate or modulate how large their gape is, which I kind of saw as, they're ahead of the times, because they don't just open it and then snap shut as kind of stereotypes in movies. So don't get that wrong. Following with the feeding theme onto the food web, these sharks have no known predators actually, but they prey on seals on the very right, going right to left, other sharks, shrimps, rays, crabs, chimeras, and fish. And they aren't a danger to humans, but if provoked, they will attack, and they will win. Onto geographic distribution, they're found in tropical and temperate waters, and some examples are the Strait of Georgia, the coast of Florida, and as you can see also just in Central America, South America, coast of Africa, Australia. They're honestly all around the world, on every continent. And even though they aren't that well known, they're probably really close to where you live, but also at a great depth. Which leads me to my next slide, at depths of 2,490 meters approximately. But however, they sometimes come up to continental and insular shelves, as I've kind of shown on the picture on the top right corner. Continental shelves are just the shelves near the continent where it's really shallow, and insular shelves are the same as continental shelves except on islands, so they're not next to continents, obviously. And some speculate that this is because their ancestors lived more towards the surface, but I guess they must have evolved to live deeper. However, them coming up to the surface has a reason, because in reproduction, I'll talk about it in a second. Well, so mating is done in deep waters, and then afterwards, the females come up, to the shallower areas to give birth on the continental and insular shelves. 6-gill sharks breathe through ovoviparity, where the eggs stay inside the mother until they are ready to hatch. And litters can be from 22 to 108 pups. So that's a lot of sharks. To finish off, thank you for watching. Overall, I've concluded that these unique features that the six-gill sharks have, such as their bite, ability to manipulate prey, their ability to exist in both depths and surface of the ocean, and their great white shark-like features, their ability to modulate their prey, etc., is what has allowed them to survive, and I think this will allow them to continue to survive. And that's probably why they didn't evolve like the five-gill sharks. Thank you again for watching.